Hello and welcome to another Science Tutor lesson. I'm your tutor Nathan, and in this video we're going to do a worked example for electrical circuits. The question is already on the screen, so if you want to take a few moments to get a calculator, get a pen or pencil and some paper so you can follow along, then feel free to stop the video and get all the materials you need. So this question asks, for the circuit below, calculate 1. The net resistance of the circuit, 2. Calculate the current flowing through the circuit, and 3. Calculate the energy dissipated by the circuit or used by the circuit if the current flows for 20 seconds. So the first part asks us to calculate the net resistance. Now resistors can be put together in a circuit in two main ways. They can either be in series or in parallel. Now for resistors in series, the total resistance contributed by each resistor is the sum of R1 plus R2 plus R3 and so on. So the resistances add. For parallel resistances, the reciprocal of the resistances add. So 1 over the total resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3 and so on. So the inverse or the reciprocal of the resistances add. So for the circuit below, R1, this first resistor, is in series with this combination of R2 and R3, which is then in series with R4. However, R2 and R3 are in parallel with each other because they share a common connection point at both the upper and lower terminals. R2 and R3 are in parallel. So the parallel resistance contributed by R2 and R3, which we're going to call Rp, is calculated as follows. 1 over Rp is equal to 1 over R2 plus 1 over R3, which is equal to 1 over 300 ohms plus 1 over 300 ohms, which is equal to 2 over 300 ohms. They share the denominator, so you can add the 1 plus the 2, and that is also equal to 1 over 150 ohms, dividing through by 2. This means that Rp, the parallel resistance itself, is equal to 150 ohms, because 1 over Rp is equal to 1 over 150, so Rp itself is equal to 1 over 150, or 150 ohms. So that's the parallel resistance due to R2 and R3. So the net resistance from the circuit, or the net resistance of the circuit, is now R1 plus Rp plus R4, which is equal to, and here you can sum the resistances because all of the resistors are in series, 100 ohms plus 150 ohms plus 250 ohms, which is equal to 500 ohms. That is now the net resistance of the circuit. So that's part 1. The next part asks us to calculate the current flowing through the circuit. Now the battery voltage is 10 volts, and Ohm's law states that the voltage across a resistor or group of resistances is equal to the current flowing multiplied by the value of R. which we can use to find the current. I is equal to V over R. Okay? So we know that the battery voltage is 10 volts, and we know that the resistance of the circuit is 500 ohms. This gives us a current of 0.02 amperes. That is the current flowing through the circuit. And so the last part now asks us to calculate the energy dissipated by the circuit if the current flows for 20 seconds. So there are a number of ways you could calculate the energy. You could either use the formula E is equal to Q times V, or E is equal to I squared times R times T. E is equal to I squared RT because we already have calculated I, R, and we have a value for T. We could use E is equal to QV, but in this case we would have to find the amount of charge that flowed through the circuit using the second law, Q is equal to IT. Right, so to save time, I'll use the second of the two equations. Right, and it's always a general good practice to use an equation or formula that meets your need. If you have a choice, choose the one that has or is closest to the information you already know. In other words, choose one that does not require a lot of additional calculations. Right, so E is equal to I squared RT. In this case, I is 0.02 amperes squared. R is equal to 500 ohms. T is equal to 20 seconds. This gives us a value of 4 joules. Right? And this is the energy dissipated in the circuit. So I hope this video was useful. If there is anything that is unclear, feel free, as usual, to watch the video over again. And this time you might want to take notes at points, or make notes wherever you saw something new for the first time, a method or principle jumped out at you, or you saw something you never saw before. Also, please feel free to leave us a comment in the comment section beneath, and to like and share the video. And I hope you stick around for the next video in the series. Thank you.